Welcome to online learning, prepared by foreign teachers in grade 6, Anuban Chunbury School. This video recording is for educational purposes only. My name is Teacher Edward. I hope you memorize my name. Okay, because we've been studying for 5 weeks already. And once again, I am your science and your health teacher. Okay, so let's have a quick review. What did we study last Monday? Who can still remember? What did we study about last Monday? I think we had our, what is that, experiment, right? We had our experiment. Who can still remember? What is that? Anybody who can tell me what did we do last Monday? What did we study about?
Filtration.
Filtration, very good. Okay, so I'll adjust some settings here. Okay, so we actually, you're correct when you said filtration. We studied what is filtration, how does filtration works, and what are the uses of filtration in daily life. Who can still remember what are the materials we use in our experiment? Can you still remember?
Filter
paper.
Filter paper, what else?
Funnel.
Funnel and chalk and water, right? So those were the materials that we've used last Monday for our little filtration experiment. Okay, and these are the vocabulary words that we studied last time. Filter, filtrate is the clean water, right? Filtrate is the clean water. Insoluble, the chalk is insoluble. Sewage, haze, and residue. Okay, the residue is the what is that? The residue is the chalk remains in the filter paper. Now, for our lesson this afternoon, it is entitled precipitation. This is not the precipitation in the, what is that? This is not a precipitation in the water cycle. You understand? This is not a precipitation in the water cycle when the water in the clouds will be full and it will start to rain. Then that is the precipitation. Wrong. That is not the precipitation that we're going to study. So this afternoon, we will know what is that precipitation all about. Okay. So for us to understand what will be our, or what is our topic this afternoon, let's watch this video together. Okay. I will make this one here, Max. If it is too loud, you adjust there on your end.
Topic: water purification. Why is alum added to water?
Aha! Because water does not like to be alone. It wants somebody's company.
Nah. Alum is added to purify water. Alum is aluminium sulfate. It acts as a coagulant. A coagulant attracts and binds with extremely fine and small particles to form a large particle.
Okay, I will stop right there so that you will be able to understand. Now, what is this thing again? This thing is called the, what is that? Alum. Okay, that is the name, okay, of the material. Okay, that is the alum right there. Now, what does that alum do? It actually, these particles here, okay, they are very, very small. And when it is mixed with water, we cannot even see it. Okay, these are the dirt. Now, when that happens in the water is dirty, right? But when we put the alum inside, what happened is that this dirt or these dirts will become large particle. Okay, they will go together. Okay, they will go together and they will form what is that? Clump. They will clump together, and then it will be easier for us to what is that? It will be easier for us to get or to remove them from the water. Oops.
Stop. Why is alum added to water?
Aha! Because water does not like to be alone. It wants somebody's company.
Nah. Alum is added to purify water. Alum is aluminium sulfate. It acts as a coagulant. A coagulant attracts and binds with extremely fine and small particles to form a large particle.
Ew, I won't use it.
But why?
Because it will attract all small insects and make a large insect.
Oh, you're just unbelievable. When a solution of alum is added to impure water, it attracts and binds with contaminants and fine suspended particles of mud, dirt, etc. to form large particles. Being large, these particles can be removed by filtration, or when they settle down due to gravity, they can be removed through decantation, giving us pure water.
Okay. So in the simplest sense, that is the definition of precipitation. Okay, when we add something in the water. But before I will go ahead of myself, let's study the vocabulary words that we need to understand first. The word here is precipitation. I want all of you to turn on your microphone and I want you to repeat each word after I will read them. Number one, precipitation. Alum.
Please to remember.
Coagulant. Purify. Decantation. Clamp. Disinfection. All right, perfect. You can now turn off your microphone. Thank you. All right, thank you. So the first word here is precipitation. Precipitation is a chemical precipitation in wastewater treatment. Okay, so we use this one to make sure that our water will be clean. Okay, it involves addition of chemicals such as alum to alter the physical state of dissolved and suspended solids. Okay, now I will pause here and I will explain a little bit what this is. Okay, so as you can see here, this is water, but there are some impurities here. Maybe there are some dirt. Okay, can you see that? There are dirts here, and then we put the alum. Can you see the green thing here? We put the alum, and then there is what we call the coagulant. The alum will serve as a coagulant. Now, what happens next is that the coagulant will actually form the forms precipitate. So the pink one, can you see the pink one here? The pink one will be gathered together. Okay, so it means they will form together. No, they are going to become a large particle. Now, when they are large enough, they will actually settle at the bottom of the water container. So this part of the water right here will be clean. I will repeat. This part right here of the water container, it will be clean. You understand? So that is how the precipitation process works. Do you have any question? No question? Okay, if there's no question, then we'll proceed. This is the alum. It is used in water treatment plants. Okay, so these are like ice. So these are very, this is actually the complete name is aluminium sulfate. Okay, the alum. Okay, the coagulant here, I already told you what a coagulant is. The coagulant will make these small particles here. It will make the small particles here to clump together. Okay, so they clump together like this. Okay, why they clump together? Because you put the coagulant. Okay, so if you put a coagulant, they are going to clump together. When they clump together, it will become like this. Okay, they will settle at the bottom of the container. Okay, so the responsible here is the coagulant. Next word is purify. Okay, remove contaminants from. As you can see here, the water here is a little bit, it's dirty. Okay, it's dirty. Then you try to purify it, it becomes like this. Okay, and then you will purify it again until it becomes clean water. Okay, and when that happens, you will be able to drink that water. Okay, so that is the meaning of the word purify. We can purify the air, we can purify the water, we can purify the oil as well, you know, because the oil, there are some contaminants as well. Okay, the next word is decantation. Decantation is the process here. It says the process for the separation of mixtures of immiscible liquids or a liquid and a solid mixture such as a suspension. So here, the sand, if you will not mix this one, if you're not going to stir the mixture, the sand will actually settle at the bottom of the container. So that is decantation. Okay, that is decantation. The next word here is the clamp. Okay, a compacted mass or lump of something. So this one, this is a clamp of sand. But based on our example here, these are the clamp of what is this? Clamp of dirt. Okay, clamp of dirt. Okay, that you can see here in our examples earlier. Clamp. Okay. And the next one is disinfection. I think you are very familiar. What is the meaning of the word disinfection? Disinfection is the process of removing harmful substances. Okay, the process of, wait, I will edit this one because the spelling. Oh no. It should be off. Okay, the process of removing harmful substances, like for example, the house of Nataya will be will have a disinfection because there is a COVID-19 there. Okay, so you're going to disinfect. For example, there are a lot of mosquito in our classroom, so we are going to disinfect the entire classroom so that the eggs and all the mosquito will be dead. So disinfection. Okay, time for our quiz. Are you ready? Okay, I will make sure that I will be able to record your scores. The same thing, this is very, very simple. I want you to fill in the blanks, okay? So here we have the words precipitation, alum, coagulant, purify, decantation, clamp, and disinfection. Okay, so I will try to record here your scores. Now I want you to answer, tell me the correct word, and after I will say if it is correct or wrong. If I say correct, then you're going to read the entire sentence with the correct answer. So number one here is given to you as an example. There is a disinfection going on in all rooms of Anuman Chunburi School. Okay, so the answer there is disinfection. What about for number two? Who wants to answer number two? Anybody? Who wants to answer number 2? A blank of mashed potatoes fell on his lap. What is the correct answer? What is the answer? Anybody who wants to answer? Come on, you can answer. Don't worry if your answer is wrong. I will not be angry. But who knows? Maybe your answer is correct, and then you will be given 2 points for today. Okay.
Clam.
What is your number?
13.
Number 13. What is your answer, number 13?
Clam.
Clam. Okay, so the answer is correct. Can you read the complete sentence, please? Can you read number 13?
A crumb of mashed potatoes fell on his lap.
All right. A clump of mashed potatoes fell on his lap. So number 13 here got 2 points. All right. Now let's go to number 3. The doctors have prescribed anti-blank to prevent such clots. Okay, the blank, anti-blank. Anti what? If our blood will coagulate, oh, I said the answer already. Okay, our blood is liquid, right? So when our blood will become, what is it? If our blood will become semi-solid or solid, it means it will be very, very thick or very sticky. Then the blood will not be able to flow properly. So you will die if your blood will not flow properly. So what is the answer here? The doctors have prescribed anti-blank to prevent such clots. What is the answer? Yes?
Coagulant.
Coagulant. Very good. Can you read, Nataya, the answer?
The doctors have prescribed anticoagulant to prevent such clots.
Perfect. Anticoagulant. Number 4. We added blank to water and small particles in the water clamped together. Okay, so what's the answer here?
Alum.
Who answered alum? Who answered alum? Number 31, Paradi. Okay, can you read Paradi? The sentence with the correct answer.
We add alum to water. Small particle in the water clump together.
Okay, very good. Thank you. Oops. Okay, what about number 5? Who wants to answer number 5? Some white solid could distilled and was separated by blank. The answer is, who wants to answer? Decantation or precipitation?
Decantation.
Okay, let's see. Very good. Some white solid could distilled and was separated by decantation. Number 24 again, right? Number 24 again. Very good. Now let's proceed to number 6. Who wants to answer number 6? Someone is paying a bill to blank the water that comes through that fountain. Pirapong, number 2, go ahead.
Purify.
Purify, very good. Can you read properly? Can you read the entire sentence?
Someone is paying a bill to purify the water that comes through that fountain.
Okay, thank you. Your score is already recorded. Last number 7, the easiest one because there's no other option left. Who wants to answer?
Precipitation.
Okay, Chontira, can you read the sentence, please?
Precipitation is another way to separate insoluble solid from liquid.
All right, precipitation. Thank you. All right. Thank you. Good, great job, everybody, those who participated. Now let's proceed to our lesson for this afternoon. Here, oops, wait. I will try to edit this one. Why this is very big? I don't know why this is very big. Okay, so you can open your book on this particular page. I don't know exactly what page is this. Can you tell me what page is this now?
37.
37. All right. So can you open your book in page 37? And then I will be able to study this together. Okay. So alum here can be used in water treatment plants. Okay. So what does this alum do? Okay, it will act as a coagulant. It will act as a coagulant. Okay, look at here. When we add alum to the water, okay, I want you to highlight this one. The small particles in the water clump together to form large particles. I'm sorry. And can be easily removed. All right. So highlight this one in your book. Highlight, please. Parinia, can you highlight this in your book so that it will be easier for you to study? Okay. So this is what we call an alum. Okay. It is used in water treatment plants. When we add this to the water, the small particles in the water clump together, the dirt and all the impurities, contaminants will clump together. And of course, if that will happen, we can remove them easily through filtration or to add any other techniques. All right. Next slide here is a video about precipitation. Okay, so I want all of you to listen or watch this video again. Okay, no, I mean you haven't watched this video before, and since there are, I think, 2 pages only in your book about precipitation, so I really tried to look for other references in the internet. Okay, so let's begin.
Let's do a small experiment. Would you rather drink this water or this water? Well, of course you would choose the water on the left. Unfortunately, some people in other parts of the world have no choice at all. Did you know that small floating particles in drinking water can make you sick? Imagine we have a super powerful microscope and we can zoom into the water. Zoom! What will we find? What are these small floating particles and how do they float? These particles are of 2 types: inorganic, like clay, silt, and mineral oxides, and organic, such as algae, protozoa, and bacteria. The bacteria, once ingested by humans, can sometimes be fatal. All of these small particles are able to float because they are not heavy enough to settle to the bottom by gravity. Suspended particles that are too light and small to settle are called colloids. When looked at together, these colloids cause a state of cloudiness or haziness known as turbidity. The more cloudy a fluid looks, the more turbid it is. Here we see 4 beakers of water with increasing levels of turbidity from left to right. There is a relation between turbidity and the risk of getting a disease. Science shows that the more turbid the drinking water is, the higher the risk of getting sick is. Now, why is this? This is because toxic compounds can adsorb, that is, stick to, the surface of the suspended colloids. The more colloids there are, the more toxic the water can become. These toxic materials and bacteria can cause cholera, salmonellosis, hepatitis A, dysentery, and E. coli infection. These illnesses affect and kill millions of people a year and are especially dangerous to children whose weak immune systems cannot provide an adequate defense. Fortunately, we can do something about this. One of the very practical ways to clean this turbid water is called flocculation. Flocculation is the process in which colloids aggregate or come together to form larger particles called flocks by the addition of a chemical called a flocculant. Typical flocculants include alum and ferrex because they work well with high turbidity fluid mixtures. Now, let's demonstrate how flocculation works. First, we'll need to go out and collect some muddy water from the Charles River. Here are 2 beakers filled with the same amount of muddy Charles River water. On the left is our control, which will remain untouched, and on the right, we'll add 3 milliliters of prepared flocculant solution. Then we'll stir for 2 minutes and wait. Wow! What just happened? The colloids in the turbid water on the left may never settle, whereas with the addition of just a little bit of flocculant, the water on the right became clear.
Okay, so basically that is the definition of precipitation. We added alum into the water and then look what happened. After we stir it, it becomes clean, right? It becomes clean.
In order to make this water potable, it will require skimming and filtration and maybe some additional treatment. If you're wondering what's going on, let's explain how this flocculant business works. Almost all colloids have negatively charged surfaces. This means that positive ions, or charged particles in water, will attract to the colloid surface, forming a first layer. Recall how like poles of a magnet will repel, while opposite poles will attract. The same occurs with colloids in water. A diffuse layer, made up of a mix of positive and negative ions, will then surround the first, forming what is called a double layer. This double layer provides a repulsive force that prevents 2 colloids from sticking to each other. Once the flocculant is added, it adheres to the surfaces of the particles, compressing the double layer and allowing the colloids to stick to each other and form flocks. These flocks are now heavy enough to settle to the bottom by gravity. Given how effective flocculation is, many countries around the world use this method for cleaning their water supplies. Did you know that Singapore, for instance, produces drinking water from sewer water using a number of methods including flocculation? As the global population increases and freshwater resources become more and more scarce, flocculation is one tool that can supply clean, healthy, and tasty drinking water worldwide.
Okay, so it's very nice now because of these processes or because of the separation technique from a very, very dirty water like this, from a very dirty water, it becomes, what is this? It becomes cleaner water and we will be able, we can be able to drink this water because it's already clean. So from here, this is a very, very dirty thing or very dirty water, it becomes like this. What is the process? We use precipitation and we can use skimming and filtration as well. Okay, so those are the things that I would like you to remember for our lesson this afternoon. Teacher Edward, why we need to study this one? we can buy water from 7-Eleven. Am I right? Not what? Here in Thailand, you just go 7-Eleven and then we will buy water, right?
Yes.
But the problem is, not all countries have the same luxury as here in Thailand. Some countries, they don't have clean water, you know, and they need to walk for very long, like how many kilometers in order for them to get clean water. So that is why this science advancement, these processes in order for us to separate the dirt from the water will become very important. Okay, so here, look at this. I don't know what page is this. Maybe this is in page 38, right?
37.
37. Okay, so here there are 7 processes that involves the water treatment process. Okay, so this is water treatment. What does it involve? Precipitation and filtration. Now let's take a look at the first one. Here, the raw water is pumped through the pipes. Okay, so this is like the water. Let's say, what are the bodies of water? Let's say river. Okay, so this one is from the river. Okay, now here in the number 2, in the second stage, what can you see here? Filter. Okay, so since we study filtration already, so it is not very difficult for us to understand. This is the filter right here. Now here, like, I don't know what this is. Maybe these are fish. Okay, let's say they are fish, or maybe there are some plastic, there are some rocks from the river, the garbage, the trash, and all of that. All the solid materials cannot enter into this part right here because of filtration, because of the filter. Okay, now here in stage number 3, what is added here? Alum is added. Okay, so the solid particles will start to clump together. Okay, since we put alum. So in this stage, they added alum. And here in number 4, since we added alum already, the small particles become large particles. Okay, they become large particles. And what happens if they are large particles already? They will settle at the bottom of the container. Okay, at the bottom. They are going to settle at the bottom of the container. Why? Why they will settle? Because they already clump together and they become large particles. But if you will not put alum here, what will happen? The bacteria, protozoa, algae, and maybe, you know, and other substances or dirt will be able to, you know, just float in the water, and we cannot see it because it is very small. All right, now when this water will be here in tank number 1, 2, 3, 4, 5. This is tank number 5, right? This is tank number 5 here. This is tank number 5. There, the water here will pass through. What is this? Filtration again. Filter, another filter here, another filter here. So there's a lot of filtration happening. So this one will make sure that the water that will pass through here, there will be no solid particles. Okay, because there is already filtration that is happening here. So the water that will be in this tank, after all the filtration here, like 3 layers of filtration, then the water here will be put to the next tank where we will do disinfection. Okay, so we're done with the filters here. Okay, so disinfection here. What is the purpose of disinfection? What do you think? Why do we need to disinfect the water? Any idea? Why do we need to disinfect the water? You might say, Teacher Edward, we use already alum, we use already filtration, but why do we need to disinfect the water in the 6th container? What do you think is still present in this tank? What do you think that we need to disinfect? Anybody? The points is waiting for you if you can answer correctly. What do you think? Chantira? Anybody? Maybe Paradi? What do you think is the material, or what do you think are other substances that are still present here in tank number 6 for this infection?
Germ.
Nataya, yes?
Germs.
Very good. Very good, Nataya. The thing here that are still present are the germs. The germs will pass through here. The germs can pass through here as well until here. But here in the disinfection, not only the germs. I will put here germs, but not only germs. It can be bacteria. It can be what is this? Algae, or it can be a protozoa. Okay, and these microorganisms, they are very, very small. We cannot see them, but they are very real. And when we are going to drink the water with these microorganisms, what happened to us? We will become sick. You understand? That is why we need to. Disinfect the water so that the bacteria and algae, protozoa, okay, will be killed. Okay, here in tank number 6. Some water treatment facilities, they actually add some minerals here. Okay, after they disinfect, they put some minerals in the water, and then if that is ready, then they will be able to put that thing in the tanks. It's stored in tanks. Okay, it will be stored in tanks. And then they're going to deliver it to 7-Eleven, and Nataya will drink the water. Where is this water from? From the river. Nataya will drink the water from the river. After all the processes involved. So this water is already clean. Okay? Or sent to different places. So that is how the precipitation and filtration, they are very, very important in treating our water, or water treatment process, so that the water from the river or any other sources will be potable or safe to drink. Do you have any question? Before we're going to proceed? Nataya don't have any question. What about the others? Don Rapoy, Supercrit, Lalada. Oh, Lalada, I cannot see your face. I am sad because I cannot see my face of Lalada Panatat number 21. Where are you? I cannot see you. It's very sad if all of you will turn off your video and only Teacher Edward will turn on the video. It seems like I am talking to robots. It's good that I can see your faces. Like what is this? Like, I have a lot of very good students here as well, like Parinia, always turning on the video. Very good, Jirayu as well. Napichayan, Natawat is number 1. Natawat is the best. Always turn on the video. If we ask him a question, he will answer. So Natawat for me is 10/10. He is very good. What about the others, like Satawit? Turn on your video, okay? If you don't have any question, we have Nataya here as well. Okay, this is another picture of the same process, water treatment process. Okay, the same thing happens here. The raw water from Chao Phraya River. Oh, Nataya, what do you think? This is from the Chao Phraya River. Do you think, Nataya, that the water from the Chao Phraya River can be drink? Okay, if we undergo precipitation and filtration and disinfection, what do you think, Nataya? Do you think we will be able to drink the water from Chao Phraya River? Yes, yeah, correct. Yeah, you're correct. Even if how dirty the water is, if we are going to do a lot of very, what is this, specific processes, we will be able to make the very dirty water into a potable water. Okay, here this is coagulation. The coagulation is that the time when you put the alum, okay, and then this thing, flocculation is when the large particles will settle here, okay, like this. And of course, if the large particles will become like this, it will be easier for us to remove. Okay, this is the process of filtration. You can see here the water. Okay, so there are different layers of filtration. After it is done, the water will go here and another disinfection, and then it will go to the house of Putisan. Okay, so that is the process of water purification. Okay, so if you don't have any question, then we're going to watch this video, another video. Okay, but I think this one is very long video. I think this is 10 minutes. So maybe we'll start somewhere here in the
treatment plants. The little river. All the wastewater from the city of Windsor ends up at one of two wastewater treatment plants. The Little River plant, or in this case, the Lou Romano plant. The purpose of each of these plants is to remove all solids and pathogens, you know, microorganisms like bacteria and stuff, from the wastewater, so when it gets reintroduced to the Detroit River, it's cleaner than when it arrived at the wastewater treatment plant. When it arrives, coarse screens remove large solids, rags, and debris from wastewater and are immediately disposed of. It's here that you see some of the most ridiculous things people have put down their toilets, drains, and sewers. At least this stuff made it this far. Some things that the water can't dissolve end up stuck in the sewer.
Okay, I would like to stop from there, right there, because it is very important for us to understand that some country, they don't have clean water. And you know, the water from different toilets, the toilet of Purama, the toilet of Nataya, the toilet of Paradi, you know, they are going to collect together. What is that? They are going to collect together. And what happened is that when we throw our tampons, tissues, garbage, and all of that in the toilet, then it will be flushed and it will be here. That's why you can see there's a lot of
sewers, leading to sewers being clogged and homes being flooded. After this, fine screens are used to remove the smaller material in the same way. Next up is grit removal. Grit includes sand, gravel, and other heavy solid materials that are heavier than the organic solids in the wastewater. Removal of grit happens by...
Look at this water. Look at this. It's very, very, very dirty, right? It's very dirty. I can even smell this one. It's, you know, it smells very bad. It's so dirty.
Getting the wastewater to flow in a spiral pattern. Heavier particles settle at the bottom of the tank, while lighter organic particles are suspended and eventually carried out of the tank. From there, that water is sent into a settling basin. This is where suspended solids settle out and floating scum is removed by skimmers. Scrapers in the tank move continuously along the bottom.
Okay, so this is an example of filtration. Can you see this one? It actually filters the, what is this? Oil and other garbages. It is being filtered, okay? So as what I have told you, it will undergo many processes so that the dirty water will be able to be drinkable or potable water.
To deposit the raw sludge into hoppers, which is sent to a nearby plant where it's made into pellets for fertilizer. After the settling basins, the wastewater is sent to the next step by an Archimedes screw pump, which forces the liquid upwards. The revolutions raise the water thread by thread until it comes out at the top of the cylinder. There, it is met by the fine curve screen, where small items that have made it through the initial screen.
Okay, I will go back a little bit. This is, what processes is this again? This is filtration. Okay, this is another filtration right here. There are screen. There is what we call the sifting.
Fine curve screen, where small items that have made it through the initial screening process are removed. Things like fruit and vegetable stickers. They don't dissolve and they clog up the system. So when you're peeling them off, throw them in the garbage, not down the sink. Now it's time to get the stuff you can't see. Some of this work is done by biological aerated filters. Essentially, what happens here is that good microorganisms attached to porous rock eat up the bad microorganisms. The wastewater is pumped up through the rocks and the bacteria in the water sticks to the rocks. Bubbles are pumped in to keep the good bacteria alive and working. The clean water goes up and the rocks with the bad bacteria attached to them go back down. This cleansed water then flows into a channel on its way to be treated by ultraviolet light. The water passes high-output UV lamps, where light disrupts the molecular structure of DNA molecules in the microorganisms. This renders the cells unable to replicate before they die. The disinfection stage takes seconds, eliminates the need for chlorine, and makes the final process much safer. At the wastewater treatment plants, more than 90% of the pollutants are removed from the City of Windsor's wastewater before the water is returned to the Detroit River. And that's important because the Detroit River and the surrounding lakes are our primary source of drinking water and so much more.
People cannot live without water. We need water for agriculture, we need water for hygiene, we need water for recreational aspects, we need water for drinking, and we have no substitute for water. It's too easy just to try to pass the blame to somebody else. We're all sharing the same resource and we all have the same responsibility.
Right now, the Detroit River is still considered an area of concern under the Great Lakes Water Quality Agreement. We have to care and protect for the resource that we're using and that we're leaving behind for our generations as well.
Okay. So I will stop right there and then we will proceed to practice time. I hope you understand something very important about this water, okay? Maybe some of you here are, you just go 7-Eleven and buy water. There are different places in the world that they don't have clean water. So, even if, for example, the water from the faucet in your toilet, maybe some people, if they will have that one, they will be able to, maybe they want to drink that one because compared to other countries, that water from faucet is cleaner than the other water source. So we need to be very thankful of the water that we have, okay? And that is why it's very important for us to study how to separate the dirt from the water. Now, let's go here because I think it will take you some time to answer this. This is found in page 36. Am I right? This is found in page 36. So, here, this is a muddy water. So, I put here a picture of a muddy water for reference. But it says here that bakers should be labeled A, B, and C. It should be 3 bakers, right? 3 bakers. And put 4 teaspoons of alum powder into baker B and C. Okay, but what is this? The first baker, baker A, the baker A will not do anything. Let's say here, baker A, you will not add alum, okay? And then the second instruction here is pour 200 ml of muddy water in each of the 3 bakers, okay? And then stir the mixture in the baker B only, okay? So in baker A, You will not stir. You're not going to mix. And baker C, you are not going to mix as well. All right. So the next part here is that, what is that? Where am I? Okay. There. I have a picture here as well. Leave the bakers aside for 5 minutes. Observe and compare the content in the bakers. Draw your observation below. So I want you to draw this one here. What do you think will happen here in beaker A? What do you think will happen in beaker A? Beaker A will become like what? Beaker A will become like this, Nataya. You understand? Beaker A will become like this. Beaker A. Okay. So I want you to draw this one for beaker A. Okay. What about for beaker B? What about for beaker B? What do you think will happen? Because in beaker B, you are going to stir the mixture in beaker B. So what will happen? What will happen to the water here? The muddy water. It will become
Clear.
what? Yes, it will become clear. So here the water here will be all clean. What about in beaker C? You added alum but you didn't mix. So the drawing here in beaker C should be something like this. Okay? Or something like this. The picture here on top. Something like this. Understood? Yes or no? What are you going to draw for beaker A? This. What about for beaker B? Just clean water. Beaker B, clean water, and this one for beaker C. Understood? Yes or no? Understood, everybody? Hello, Supakrit, you understand how are you going to do this one? Yes, or no? Okay, good. So I will give you maybe 1 minute or 2 minutes. Here you're going to color. Of course, you color it. Color it brown. Until here, brown. This one is very clean. Okay, just like pure water. And here, half of it or water here, and then the mud will be here. Okay. And I want you to answer here. What does this experiment show? Okay, what does this experiment show? So you're going to write your answer here as well for letter B. So you only have to draw this. You're going to draw this as well. And this. And after that, you answer here for letter B. And we will be finished. Okay. Done. Last 1 minute. Okay, time's up. Time's up. Are you done? Okay, so we are going to let me see your what is this? Let me see your answers. Let me see your book. Why you are not turning on your video? Please turn on your video and show me your notebook. Where's your notebook? Okay, Chontira, very good. Parinia, let me see. Apiwat, Apiwit, Dirayu. Okay, perfect, perfect. Pirapong as well, very good. All right. Okay, so I will not check this one because I already told you the answer, right? So I hope that you're going to answer this one. But if you haven't answered, then maybe it will serve as your homework. If you haven't finished answering yet. Now let's proceed to this part of your book. May I ask somebody here to tell me what page is this in your book? What page is this in your book, everybody? What page is this in your book, everybody? Jennifer, what page is this? Or do you have this one in your book? Yes or no? Do you have this, Chuntida, in your book? No? Are you sure? No? Natawat, do you have this in your book?
No.
No. Oops. No. Are you sure you don't have? Okay. If you don't have, it's okay. No problem. Okay. Now I want all of you to turn on your microphone. Okay. I want you to turn on your microphone and we are going to answer together. Yeah, we're going to answer together. So this is just what is this? This is just a summary of what we have studied last time. Okay, what did we study last time? We studied about filtration, sifting, using magnets, and today we studied precipitation. Okay, so I want all of you to turn on your microphone and let's ask all to unmute and you are going to answer here. Tea leaves in a cup of tea. Where are we going to put here? Filtration, precipitation, using magnets, or sifting? Anybody? Where are we going to put this one? Tea leaves in a cup of tea. Nobody wants to answer? Nobody wants to answer? What about Napichaya? What do you think is the answer here? Filtration, precipitation, using magnets, or sifting?
I don't know.
We don't know. What about Jirayu? This is like leaves and let's say this is leaves and water. How can we separate the leaves? The leaves and the water. What's the answer, Jirayu?
Filtration.
Filtration, very good. Any other answer, Parinya? Do you have any other answer for this?
No.
We can also use sifting. What about nickel coins and wood chips? Who wants to answer?
Using magnets.
Using magnets. Is there any other answer here? Filtration, dai mai? May dai. So we are going to proceed here. Iron fillings and sand.
Using magnet.
Using magnets again. Okay, what about fine dirt particles mixed in water? This is our study today. What is the answer?
Precipitation.
Precipitation. Very good. Thank you. What about fine flour and plastic beads? Fine flour and plastic beads.
Sifting.
Very good. Sifting. What can we do filtration? What do you think? No. Okay. Maybe. Wait. I will try to. Wait. I will try to look if there is any. Wait. What's the problem here? Okay. Okay. So there, no other answer. Fine flour and plastic beads will be connected to sifting. I want you to screenshot this. Okay, screenshot, take a picture, or if you want to copy in your notebook, now is the time. Okay, now is the time because it will enable you to study faster. Okay, So while you are doing it, I will try to check your attendance as well. Okay? So do not go anywhere. Okay? Where is number 8? Is Natchanan here? Natchanan is not here. 10, 11, 12, 13, 14, 15, 16, 17. 23, 24, 25, 26, 27, 28. What about number 29? Disorn. Where's Disorn? Is Disorn here? Not here. Pichaya. Okay. Present. Paradi as well. 32. 33, 35. 36. 37, Wiriporn, are you here? Not here. And we have 39. All right, perfect. So there are, how many students we have here? 36. So very few students are absent. Are you done copying? Yes or no? Okay. So that concludes our lesson for this afternoon. Thank you for participating. And good job, everybody, to those who received. And that's all for today's online learning. Let's have a review. The things that we studied today are all about, are all about here. Okay. Precipitation, alum, coagulant, purify, decantation, clamp, and disinfection. Okay, so these words are the things that we studied for today. I hope you will be able to remember them. Okay, and then if you want to, what is this? Okay. So again, we have a shifting. There are a lot of people who are getting vaccines right now, but there are a lot of people who are having COVID-19 still. So always remember to stay safe from COVID-19. Okay? So I want you to turn on your microphone because now is the time to turn on. Elena, now is the time to take a picture of all of you. We are going to take a picture. And I want you to turn on your camera. Okay, and then wait, what is happening here? Oops, Mamma mia. Okay, 1, 2, 3. Smile. Oh, wait. Do not smile yet. Do not smile yet. Wait. I will try. Okay, I will. So wait. I will stop recording. Wait, what happened here?